Hello and welcome students to several examples of how we use the definition of derivative to find f prime of x if we are giving f of x. Now, what do we mean by definition of derivative? Definition of derivative is this definition, which means we need to find the derivative using the limit. So f prime will equal to this limit. We need to evaluate this limit as we just did in the previous lesson. So if we start directly, we need to write what do we mean by definition of derivative. So definition of derivative will be just the limit as h goes to 0, and then here we have f of minus f of x divided by h. Now what do we write here? Inside we will write x plus h. So remember, we have f of x, it will go as is, and then we have to write f of x again, but we will replace every x we see with x plus h. And that's the definition that we need to do. Let's see how this will turn out to be. So h goes to 0. And here is my advice. The first step, write f of x and put a minus in front of it. So there is a minus. I open a bracket. And here I need to write what is f of x, which is the function that is given to me in the question itself, which means it is 10 minus 7x. Down here, just keep the h. Now the question is, what shall we write here? Again, you need to write everything in the original function, except whenever you see x, you replace it with x plus h and keep it between two brackets. It will be much more helpful to us. So it will be 10 minus 7x plus h. Of course, this one I have to write it with a different color, because here I should write x, but now I need to write it x plus h. Now, the next step, we need somewhere at some point to cancel this h, which is in the denominator. That's what we will have to do at some point. So the first step, let's distribute the 7. Let's distribute the minus, and then we will see what we are going to get. So this would be equal limit h goes to 0, and then we divide by h. 10 is 10 minus, remember, this 7, if it goes there, it will be 7x, and then negative 7 with h, it will be negative 7h. Next, negative with plus, it will be negative 10. And finally, we'll get negative with negative. This time, it will be plus 7x. Now, let's zoom in and look closely. Can you see we have 10 and we have negative 10? They will cancel each other. We have negative 7x plus 7x. They will cancel each other. The only term that will survive is negative 7h over h. So if we go to that, continue on the same thing, final answer here will get equal to limit h goes to 0. Let me go back here and check. Cancel 10 with negative 10. Negative 7x plus 7x, so it is just a very short term. So lucky day here. We get negative 7h over h. And now the cancellation is even clearer because I can cancel the h in the top and the h in the bottom, denominator and numerator. So if we cancel h and h, the only thing we will get is negative 7. And we know that the limit of any constant, if there is no h anymore, this answer will be the final answer for our question. And that is the derivative of the function. So hence derivative is f prime of x equal to -7. And that's the answer for the question. Let me just repeat it very quickly here. In example number 2, I'm giving a question to find the derivative, but this time using the definition. I given this function. What I did, first step, I wrote this definition. Just keep it in mind. This is the definition that we will need over and over. Next step, what I did, instead of f of x, I write the function in the question. And then I write it again, but instead of every occurrence of x, I write x plus h between brackets. And that's what I did here. What I did later, I took -7 inside, I negative inside, I reach to this long expression. Lucky for us, 10 cancel with 10, -7x plus 7x, so I remained with -7h over h, and h with h would get cancelled. I get the limit of -7, and the answer is just -7. So the derivative is -7. That's how we find the derivative using the definition. So every time we ask you to find the derivative using definition, what we mean actually is exactly the limit. Let's go to example number 3. Again, use the definition. Later on, we will teach you how you find the derivative, but not using the definition, using some formulas. But since the starting point for us is to find the derivative using definition, that's what we are going to do. Now, of course, we get more complicated function. However, our step definitely would be the same. We'll start with the definition of derivative. Next step, we will write the minus here, and here we will have to write f of x as is without doing any changes. So we will write x squared -8x plus 1. Now, in the denominator, we write h, and here, what shall we write? You will write the same function, but every x you see, you write x plus h. Every x, you write it x plus h. And that's how you will solve the question. So it will be, instead of writing x, I need to write x plus h, and that's it. That's all what we are going to get. What do we do next? Well, we will go for them term by term, deal with them. For example, the first term is something squared. It is a plus p all squared. And you remember, this is a squared plus 2ab plus p squared. This is the formula how we expand the square. We will write it down here. We will expand it. Of course, a is my x, b is my h. Next, I have 8. I will get it inside the bracket. Next, I have negative. I will take it inside the bracket. And then, hopefully, we will have a kind of cancellation here and there. So now, start with the first one. So, if we take x squared plus 2xh plus h squared. Why is that? If I zoom in, and zoom in, this is a plus b all squared equal a squared plus 2ab plus b squared. This is the formula how to expand the square. That's how we do it. Next step, I have -8. I will take it inside. So I will get -8x, -8h. I have a +1. I keep it. I don't do anything with the +1. Next step, you take the -1 inside everything, which means it would be -x squared plus 8x minus 1. Let's see if we can cancel things out. I can see that I can cancel x squared with x squared, negative 8x with plus 8x, plus 1 with negative 1. That's a very good, useful cancellation. Let me cancel it here in front of you. X squared with x squared, negative 8 plus 8 plus 1, negative 1. So what is surviving here is this, this, and this. Let's go to the next page, write them down, and continue solving the questions. So here we have equal limit h goes to 0. So the one term survive is this one plus this one minus 8h divided by h. Now, can we cancel h? Not yet. We need to take h as common factor. We have h, we have two h's, and we have one h. Take it as common factor. If we take it as common factor, this is h. What will be remaining? It will be remaining 2x plus one of the h's minus 8. Now we are very good situation because we can cancel h and h. So finally we have reached, or what's left for us is 2x plus h minus 8. Now how do we solve such a limit? Remember, direct substitution. Substitute h equal to 0 and see if you get a number, or if you get 0 over 0, then there is a problem. Otherwise, whatever you get, you will just write it down. So if you write h equal to 0, whatever you get is 2x minus 8. And that's the derivative. Hence, f prime, which is the derivative, equal 2x minus 8. And that's how we find the derivative using the definition. Remember and recall that the answer might has an x, that's fine, but it cannot have an h because we will put h equal to 0. That's, we keep it in mind. We'll continue to another example, which again having the same idea, just matter of how we use the derivative. So let's go to example number 4, which is a straightforward example. We have to find the derivative using definition, but this time f of x is a constant function. So it has no x. Let's see what will happen. And this will be a rule and a formula that we need to memorize because it will make things easier. So if you remember what we need to do, first step, we write h here, and here we need to write f of x as it's given to me in the question. It's only given to me c. There's nothing else. Now, what do we need to write here at the beginning? Here, we go to the function. If we see x, we replace it with x plus h. That's it. But I don't see any x. So I will change nothing into x plus h. So what's remaining will be c. Good. Now, c minus c is 0 divided by h. Now forget about this limit. 0 over anything. 0. So it will be limit h goes to 0 of 0. So the final answer would be just 0. So the derivative of the constant function is 0. Remember, this will be a rule. We will write it later on the board and everywhere. Whenever you see a constant function, the derivative will be 0. And here is the proof, and here is why it is always 0. Remember, this is not 0 over 0 because h, we are not saying h is exactly 0, but we are saying h is very close to 0. So it is not yet 0. It might be 0.000001. So 0 divided by that number will still be